Welcome everybody. This is question number 7 and we will be working this question out. So let me write the question. The masses of 60 parcels at a post office were grouped and recorded. So you have the figure there. I'm posting or I would say I will place the figure on the screen now. You can see that histogram. And what we have to do is we have to complete the table given. So let me draw this table for you all. So this is actually given and all we need to do is complete it. So okay. So this is mass in kilograms, number of parcels, and this is cumulative frequency. Between 1 to 5 kgs, we got 4 parcels. The cumulative frequency is given as 4. Between 6 to 10 kg, we got 10 parcels. The cumulative frequency is given as 14. Between 11 to 15 kg, we got 17 and the cumulative frequency is 31. Between 16 to 20, we are not given anything, we have to fill this up, but the cumulative frequency is 46. Between 21 to 25, we are given 11 parcels. We are not given anything here. So next is 26 to 30. We are not giving anything here, but we are given 60. So to show it explicitly, let me draw the demarcation line so that you have an idea of what is going on. Okay, so these are the informations that we have to provide. Now clearly cumulative frequency operates like this. 4 added with 10 will give you 14, 14 added with 17 will give you 31. Now you have to figure out what you need to add to 31 to get 46. Clearly it is 15. Similarly, what would you get when you add 46 with the 11? Clearly it's going to be 57. What should you add to 57 to get 60? That's going to be 3, right? That's all, straightforward. Now you can either do it like this or you can go to the figure, the histogram given, and you can spot the things out from there. But I would suggest this technique to be followed because it's numerical and it's quite easy. So this is the solution for the question 1 and 2. Okay, so this completes the 2 questions. Now we have to draw the figure. So let me write the question that for you. So this is the question. On the grid provided, use 2 centimeter to represent 5 kg on x-axis and 2 centimeter to represent 10 parcels on y-axis, draw the cumulative frequency curve for the data. Okay, now for this we have to create a table. So let me show you how to do that. Okay, so as I mentioned to you, to draw the cumulative frequency curve, we need to have one more column. So what I'm going to do is I'm going to divide this over here so that I can bring in one more column. Okay, now this column is called as the upper class limit. UCL is the abbreviation. Now we are given mass from 1 to 5. Now I will add one more data point as 0, and clearly number of passes is going to be 0 and the cumulative frequency is 0. So this is to gap the gaps in the data, right? Or I would say to cement the gaps in the data. So that's the best word to say. So now the upper class limit for this data point will be 0.5. For mass between 1 to 5, the upper class limit is going to be 5.5. For this is going to be 10.5. For this is going to be 15.5. For this is going to be 20.5, 25.5 and 30.5. Now to draw the graph, what should you do is to set up the points. So first point is I want to know the parcels which are about 0.5 kgs. Are there any parcels there? I look at the cumulative frequency, it's just 1. This is the first data point. No, there aren't anything. This is 0. Right? 0. For weight about 5.5, are there any parcels? Go to the cumulative frequency and spot the number. So there are 4 parcels. So for weight around or about 10.5, are there any parcels? The number of parcels is 14. For weight about 15.5, the number of parcels are 31. For weight about 20.5, the number of parcels are 46. The weight about 25.5, the number of parcels are 57. For weight about 30.5, the number of parcels are 60. This is cumulative frequency, remember that. Okay, so this is our data point. Now it states that 5 kg along the x-axis, so 2 centimeters represents 5 kg on the x-axis. So we have to draw that. So so this is going to be my y-axis, and this is going to be my x-axis. Probably I'll start it over here. Okay, so this is my x-axis, this is mass in kg, and this one would be number of parcels. Okay, is my y-axis. Now the weight is starting from 0, right? So we will have to mark that. So it's going to be 0. Every 2 centimeter represents 5 kg. So this is 5. We got totally 30 kgs, right? So 10, 15, 20, 25 and 30. Okay, fair enough. Over here, the number of parcels, every 2 cm represents 10. So 10 in number, so this is 10, 20, 30, 40, 50, 60. Okay, fair enough. We are getting there. So first and foremost thing, about 0.5. 0.5 is somewhere over here, because this is 0 to 5 kg. 0.5 will be somewhere over here. So this is the starting point. We don't have anything, so we start here. Now about 5.5 will be over here, right? Because this is 5 to 10. In the middle will be 7.5, right? 2.5, 2.5. So 5.5 will be over here. So how many we got? So it's 4. So 4 will be somewhere over here. That's the first point. Now the next is 10.5. 10.5 will also be over here. For 10.5, how many we got? We got 14. Right? So 10.5 is 14. 14 will be over here. And 15.5 is 31. 31 is over here. And then 20.5 you got 40. 20.5 you got 40. So it's over here. 20.5 comes over here, right? Somewhere over here, and then 40 is over here. Okay. So moving on, 25.5 is over here, and 57 is closer. Okay. And 30.5. So I'll mark it as 35 here. 30.5. 30.5 kgs would be 60. So this is going to be the point. Okay. The graph is not to scale, right? So you connect this using free line. Okay, this is how it's going. Probably if you are drawing it on a grid line, probably it will be much curvy like this, because probably I would have, instead of going as a bump here, I could have drawn it like this. But anyway, this is the chart for the mass in kgs versus the cumulative frequency. Okay, so next step is we have to find out the median. Now what you can do is, okay, you have written out everything here, x-axis and number of parcels. That's fair enough. So let me proceed to the next part. The next part is they're asking us to find the median mass of the parcels. Okay. I'm going to find out the median for the parcels. So we got totally 60 parcels. You divide by 2, you get 30. So the median is actually occurring at somewhere in this range, or I would say this would give us the median kg or median mass of the parcels. Okay, so if you were to go to 30, okay, you go to 30 and you draw a dashed line and you drop it. Yeah. So this is going to be giving you the median mass of parcels. Now, since you're working with a grid, you will be able to find this value. This would be approximately 15 point something. I'm not very sure what the value is going to be, but it will be approximately 15. Now, I'm going to give you the mathematical way to extract that value. Okay, so this is purely from the mathematical formula. Okay, so what value is this? Now, to get that median mass, we have a formula. That formula is L plus N over 2, negative capital F divided by small f times C. Okay, I'm going to give you the values or the representation for L, N, F and C and small f. So let me give you that. Now L stands for lower class boundary of the median class. Now what is the median class? Check out here. The median is actually occurring over here. 30 numbers, right? Total number of parcel 30. So you see your cumulative frequency here. So this is our point that we will have to catch. So in this case, our L would be, okay, so let me write the terms first. N is the total frequency. Total frequency. So what is the total frequency? Okay, anyway, I will give in all the information once I state these variables. L, N, F is the cumulative frequency before the median class, and F is the frequency of the median class, and C is the class width. Okay, so L is the lower class boundary of the median class. Now, I mentioned to you 30 is our median. So you have to go and figure out where do you see this 30. Now this 30 is actually occurring between 14 and 31. Isn't it? So this is going to be the point where we will have to get the median or lower class limit. Okay, but since it is a lower class limit, we go to this value and take that as our L. And why? Because of the fact that it is the lower class limit. So in this case, L is equal to 10.5. Now n, total number of n given here is 60, right? And f is the cumulative frequency before the median class. So this is our median class, I mentioned to you, but the cumulative frequency before this is going to be 14. So my f is equal to 14. My f, small f is the frequency of the median class. So what is the frequency of the median class? This is the value. Okay, 17. And the class width is given as 5. So we will have to substitute all of this into formula. So let me write that down. So median is equal to 10.5 plus n divided by 2, that's going to be 30, minus f is going to be the cumulative frequency for the median class, that's 14, divided by frequency f is 17, multiplied with the class width 5. So this can be simplified. It's 16 over 17 times 5. It can further be simplified as 10.5 added with 4.7, which is giving us approximately 15.2. So the median mass. So what is the interpretation? The interpretation is half of the parcel have a mass less than 15.2 kg and the other half have mass greater than 15.2 kg. Okay, so this is the conclusion. Now you don't have to do all these things for your exam, right? This is just the mathematical way how to ascertain what we are doing is correct or not, because 15.2 is an approximate value and that would agree with the value that you get from the graph. But this is important. This interpretation is important. You will have to write this interpretation, not the working of this mathematical steps, I would say, to get the median mass of the parcel, because that is not required. This is additional information for your knowledge. Okay, additional info. Okay, so I will mention to you this is the conclusion of this particular question. So we move on to the next one.